Start recording. Okay, welcome to week 4, day 1. So today we're going to be talking about how arrays work in assembly, and also kind of how they work in C as well.
Stream?
So you just heard, yeah, strings, right? So
No, stream.
string.
Not string.
Stream?
Like stream.
You want to stream my string?
Stream, yes.
There you go. It's streaming now, right? Okay. So yeah, we're going to be talking about strings in C and how they work. We're going to be talking about how arrays work, how to do memory accesses in assembly, and you're going to get your next homework assignment, which is based on SpongeBob, right? So if you guys are familiar with the SpongeBob meme, you can change assembly as a great programming language into assembly as a great programming language mocking SpongeBob style. Okay? And depending on which random seed you pick, it'll capitalize them differently if you see the differences here. So we did this in 40, yeah, but now you get to do it in assembly, which is harder. Okay, so let's see, and so I've got Shakespeare and things like that loaded up for the test cases, so you'll get a SpongeBobify Shakespeare as well. One thing you should note is that like the punctuation doesn't get uppercase or lowercase, right? Only the letters do. Okay. So you're welcome to use the CC type library or the C type library as it's called in C. In C++ it's called CC type because it's the C type library. But in C it's just called C-type. But for this assignment, we're using C++, not C. And the reason why is because doing strings is super annoying in C, which is why we're teaching that today. And I didn't want to do it because what I did at the beginning of this program is I was reading in a file one line at a time and building a string up one line at a time, and doing this in C is super annoying. It's just, it's not super annoying, it's just annoying. It's like a moderate level of annoyance. It's not the worst thing in the world, but it's annoying. Because the C language, the single greatest annoyance with C is strings. And the string class in C++, which according to Matt and Zach, they had to re-implement at the Irvine level, is one of the best things since, I don't know. Is sliced bread really that good? I guess it's nice. I mean, I kind of like slicing my own bread. So you can make it thicker, slice of bread, but whatever. Okay. So, yeah, so for this assignment, it's going to, you're going to read in a random seed, you're going to open a file, and one of the nice things about my C library is you can just embed a read in the middle of a constructor, right? And so you don't have to make a variable waste that name in the current scope. You can just open it like that. And I was doing that with the seed as well, except I actually need to use the seed again because it's going to run the C++ code, then it's going to run the C code, or the assembly code, and it's going to compare the two of them. And so if your code is correct, it'll print, congrats, your program is correct. If your code is wrong, then it'll print your code's wrong. And so basically it's going to run the code this way. And it is... this code won't compile. Shoot. Okay. Hopefully none of you guys have modified this yet. Yeah. Let's just make sure this will compile C++-C main.cc. Okay, good. Sorry about that. Okay. Sudo deploy homework cside 45 s6 asm SpongeBob. Overwrite. Okay, so sing does not exist. Oh, yeah. C35. Sing 084. There's 2 sings in this class, or were. Now down to 1. Okay, that student no longer exists. Cool. All right. So yeah, where was I? Awesome SpongeBob. Okay. So what this code is going to do, it's going to open a file, it's going to read all the stuff out of the file, and it grows one string C++ style you guys understand this code here? So while the file still has data in it, you can think of it that way. It reads a line at a time from the file. If it hit the end of file, it breaks, and then it concatenates that line to the string, and it will build one string that holds the entire file in it. Okay. Can you imagine telling your own time on asim if? Yeah. So the part time of 40 wasn't quite accurate. That I got down to 40 if I put the asim code into the C file. We can talk about that in a second, but basically, if it was in a separate file, then the optimizer couldn't do as much with it. And so my actual running time was about 60 milliseconds on the last assignment, and not 40. If I put the code into main.c, then the optimizer is able to optimize it and inline it out, which was able to drop the running time from 60 to 40, which is a pretty significant speed increase. Okay. So, but do you guys understand this? Do you guys understand what's happening here? This is opening a file, and it's growing one string to encompass the entire file. Yeah? Okay. And then I'm deleting the last new line on it, just because, I don't know. For the one-line test file, like, it looks a little bit better not having that extra new line on it. Okay, because we do a end line at the end anyway. Okay. And so here is some new bad mojo for you guys. All right. So this is how strings work in C. So a string in C is just a pointer to a character, right? And one of the big problems with why this is bad design, and C people will oftentimes just absolutely refuse to acknowledge this is a problem, but it's a real problem, is that let's say you have a char C that's set equal to a letter, and let's say you just want to make a pointer to it, you know, you can do this. This is perfectly valid C, but this will break literally everything, because whenever you see a char star in C, like, everything assumes it's a string. And what a string is in so this, if you pass this to basically anything, it will probably corrupt memory or segfault or whatever. But this is valid code, right? Like, you just have a pointer to a character. It will explode everything, and it's just really garbage design, because you don't know when you take a char star as a parameter. You don't know, is that a string or is that just a pointer to a character? There's nothing in the type itself that contains that information. It's up to the programmer to know what's a pointer to a character and what's a string, and maybe you don't make pointers to characters that often, but it doesn't matter. The whole point of the type system is to stop things like that. The whole point of the type system is to notify the function what it is being passed in. And by just passing in a char star, you don't know, is it a pointer to a letter, or is it a pointer to an array of letters? They have the exact same type. The type does not constrain the function adequately. Okay, and that's why it's way preferable to have a function that takes a string, you know, a C++ style string, because then you know it's a string versus a char, right? And you can pass a char by reference, like in C. In C, there is no call by reference, right? But in C++, you can do this. And so this would tell us that we are passing a single character by reference to this function. Whereas if you pass a pointer, you don't know, is it a pointer to one character or is it a pointer to multiple characters? That is not included in the type information in C. And that's one of the reasons why I don't really use call by pointer very often, because pointers can point to one thing or they can point to a bunch of things. Is it an owning pointer? Is it a non-owning pointer? What does it mean to be an owning pointer? An owning pointer means I now own that memory address, and when I'm done with it, I should destroy it. So, you know, at the end of this function call, if I'm an owning pointer, I'm obligated to destroy it because I'm now the owner. I either have to destroy it or I have to pass it back. You know, and if the return type was like char star, then I'd pass ownership back to somebody. But in a situation like this, if I was the owner of that, if you transferred ownership to me, then it's my responsibility to destroy it. And tracking ownership through, like, you have people mallocing things. Malloc is the C version of new. When you malloc something, you're the owner of that memory, right? Do you guys remember in CSI 41 how we talked about every new needs a delete? For every master, there is an apprentice, you know, the Sith Lord rule. It gets really complicated when you have malloc, and malloc gives you a pointer, and you're the owner of it now. If they hand you that pointer, at some point, somebody needs to call free. Free is delete. Okay, so in C, you do char star foo equals malloc, and you typically cast this to a char star malloc, and I want 100 bytes of memory, and so this will make 100 chars. It allocates a block of 100 bytes of memory, and it casts it to be a char pointer, and you're now the owner of that block of memory. If you don't do this free, you have now leaked memory, and you're a bad person, and you should feel ashamed about yourself. And so when you pass just a char star to a function like this, that contains no information on if you own that memory or if you don't own that memory. And so when somebody writes a function, like, you don't know, should I delete this when I'm done with it? Because if you pass this in a non-ownership sense, like this function is, all this function does is modify it. It doesn't delete it, right? This function will take a string and randomly change letters to be uppercase or lowercase. It doesn't actually own it. It is a pointer to somebody else's owned block of memory, right? So it's owned back down here. This is where we own it, and so it's our responsibility to destroy it, which we don't actually do. So let me go put that in real fast. It actually doesn't matter because it's the end of the program, but yeah. So delete square bracket stir1. You might notice that I just wrote this code for you guys right now in honor of Matt and Zach coming to speak to us. I decided to do SpongeBob. So this will delete them. Okay, g++ -c main dot c. Let's get rid of that guy. Okay. What a garbage way to handle strings. Yes. Honestly, I don't mind the C language. I do not mind the C language. I actually like the C language. The trouble is strings are garbage. I'm just gonna, that's a hill that I'm gonna die on. It's really annoying. And there's a couple reasons why it's annoying. For one thing, so let's say you just understand that if you get a char star, you're talking about a string. And that's very common. It's very common that in C, if you just see a char star, it's never going to point to a single char. It's going to be an array. The type information doesn't help you there, but by convention, why would you make a pointer to one character, right? Like, you know, they don't do that. So, fair enough. So, here's the thing. How long is this string? Right, because a pointer is just an int. That's all a pointer is. A pointer is an integer, and it's a RAM address. It's an address in RAM. That's where the string begins. Where is the end of the string? It's not included in the type information, right? You can't actually know from this where the end of the string is, or if the string really exists at all. I mean, honestly, we should start this off with if not string like return, right? That's actually probably something we should do, and maybe you guys shouldn't be editing your homework at all right now because I'm editing it so many times. Okay, I was writing that while Zach and Matt and Christian were talking. So yeah, exactly. So the people on Discord said you read the string is valid until you come to a null character. You read until a character is 0. And so basically, if you've got hello world, it'll be HELLO space WRLD 0, and it's the 0. It's not like letter 0, single quote 0. Single quote 0, like if you do char C equals single quote 0, that's actually ASCII code, I don't know, 40 or 50 or something like that. I don't have the ASCII chart memorized. 48, I was actually in the right range. Yeah, so the ASCII code for the letter 0, and I'll say the letter 0, even though it doesn't make a lot of sense, that's when you do single quote 0, that's actually the number 48. It's literally the same thing as if I had come in here and typed char C equals 48. This is literally the same thing as if I'd written that. The single quotes, all they do is an ASCII table lookup. Whenever you do single quote something, it just does an ASCII table lookup, and it's literally, and it just replaces it with a number. So what the end of the string is, though, is not ASCII character 0. It's ASCII code 0. So the very top of the ASCII table, if you pass in 0, a 0 byte, that is a null character. In C++, you can indicate it with single quote \0, and that means end of string. Okay. And if you forget to pass an end of string, then the code will run forever. And every single standard library function in the C++ language has a possible infinite loop in it if it doesn't get a null character. And what does it take to not have a null character? If your code accidentally has an off by 1 error in it, which they all do. Every new programmer ever who has written their own string library has had an off by 1 error one way or another, because all the strings are one too big, right? So if you want to hold 5 letters, hello, H-E-L-L-O, you need 6 bytes to hold that. Why? Because it's H-E-L-L-O 0, right? H-E-L-L-O 0. And so you need 6 bytes to hold 5 letters. And if you want to concatenate 5 letters and 5 letters together to make hello, hello, well, now you have a 6-byte string and a 6-byte string. You would think, oh, I need a 12-byte string. No, you don't. You need an 11-byte string, because 5 letters, and a 0. And so, trust me on this, I have taught this class before, the one that Matt and Zach took, where you have to make your own string class. Like, literally half of my data structures, like we were making string functions and things like that, and everybody gets an off by 1 error. And so if your code has an off by 1 error in it and you accidentally overwrite that 0, guess what? Every standard library function in the C language will run forever, because they run until they hit a 0 character. And if you just happen to not have any 0 characters in memory, the code will infinite loop, or until it segfaults. It'll just run for like 5 minutes, and then it hits an end of a segment somewhere, and then it explodes. And it's a really garbage design for a language. And they did this because the C language doesn't really have classes, right? So the C++ language has classes, and so you can make a class that has a pointer to an array of characters, which is basically the same thing, but it also has a length in it. All right, so you can call str.size and find out how many letters it is, and then your code won't run forever, right? Even if you mess up on the null character somehow, it won't run forever, because you know actually what the size of it's supposed to be. And in C, if you want to know how big a string is, you can't. It's an order in operation to find out how big a string is. If you want to find out how big a string is in C, there's a function called strlen, and so you pass it a pointer, and then it's going to sit there and it's going to count. It's going to go through memory until it hits a null character, and so that is an order in operation to find out how many letters is in a string, and in C++ it's order 1. It just returns the length of the string, which might be held in a integer or something, or it could be held by a very common trick in C++ is you don't actually hold the length of a vector or something like that. You have a pointer to the beginning, you have a pointer to the end, and if you ever are asked what the length is, you just subtract the two. So that's pretty common, and so you do that because you can push back very quickly when you have a pointer to the end of the string. So null character, yeah, but if there's a problem and there is none, stuff goes very, very wrong. Yeah, like strlen can infinite loop. Like your function to find out how big a string is can infinite loop if you make a mistake and you accidentally overwrite that null character with an exclamation mark or something. Then strlen, just the function you're going to use to find out how big the damn thing is, can run forever. It won't, because there's going to be some null bytes in memory somewhere. But it'll be like, hello world is 900 bytes long. You're like, what? No, it's not. What? And it's because you accidentally overwrote the null character. It's a really garbage design. But why am I teaching it? Because you're going to encounter it later in life at some point. I've shielded you guys from the harsh reality of C-style strings until now. But guess what? You get you get to mess with it. So that's what you can have fun with. This assignment, it's a pretty, you're not going to have to be concatenating strings or deleting characters from strings, which are really annoying to deal with, because you have to, every time you do anything, like where you're changing the length of the string, you have to do a new allocation. So you have to call malloc to allocate more memory, you have to copy all the bytes over, and then you have to call free on the old one. And you do that literally every time you're trying to do something like that, like where you're growing a string, calling pushback or something like that. And so you can see here kind of what it looks like. So basically, I read in a whole file using C++, and then I'm going to convert it to a C-style string for you guys. You can have all the fun and excitement of messing with C-style strings, which should make you a little as sick to your stomach as eating Taco Bell. So, could you write your own size in C? You can't. You can't write your own. There are no templates in C. You can make your own class in C using structs, and so that's a fairly common thing to do, is for people to have a struct that is a char pointer and a size. So, my application, Sterling, yeah, okay. So what's going on here? So this is going to allocate memory. So it's asking how big is the file that we read in, how many characters did we read in, if it's like 100. Then it allocates not 100 bytes, it allocates 101 bytes. 101 to hold 100 bytes, because remember, there has to be a null character at the very end. And same thing for this one, we allocate 101 bytes to hold 100 bytes. And then this is strcpy. There's a whole string library for C. And the C string library is called C string. And you can now go through your whole life without needing it. Back in the day, it was sometimes incomplete. You had to sometimes use it anyway. But nowadays, you can kind of go your professional career without really knowing it, until you start dealing with like system calls. And so like the Linux kernel is written in C, and so it takes C-style strings. So if you guys are ever going to do system calls, which you will, it's all C-style strings. It's like when you read from the keyboard, the basic system call to read gives you a block of memory, right? Like, it will give you a block of memory of that size. And so you have a pointer, and it's like, all right, here you go. I just wrote 50 bytes of characters at this memory address. And that's, kind of what you have to do if you're working with the Linux kernel at all, which you will in this class. And so, yeah, you got to include that. You got to include that null character, right? That's why that's +1. The +1 is to hold the null character. And if you don't know about the null character, then all of your code will infinitely loop, or just give radically wrong things. And so strcpy copies from one string to another, and so you have to. It doesn't do an allocation. It doesn't do an allocation. And so if this string isn't big enough, like if I were to just for the hell of it make this -101, the strcpy will very happily copy from the file into that block of memory I give it, and it will just overwrite. It will just overwrite memory. Strcpy is a very dangerous function. It's a very dangerous function. And in fact, you probably shouldn't use strcpy. There's something called sterncopy that puts a cap on the number of bytes that are copied, and that cap should be the smaller of the two sizes of the two strings, right? In this case, it's not a worry, because I actually know very precisely how big both strings are, right? This guarantees that both strings are exactly the same length. And so sometimes, though, the compiler will actually warn you if you use strcpy. It's like, don't use strcpy, use sterncopy. Because that line of code right there, strcpy, that has probably been responsible for more hacks, like security, vulnerabilities hacking, like not like fun hacking away on your computer, but like actual, like they've compromised the Pentagon, style hacking, that function right there. Because if you do not have exactly the same size on both of those strings, the possibility exists that the one string overwrites the other string, and it will start overwriting memory. And so what you'll do is if there's an open WebSocket and there's a web server, you write to it, what's your username? And maybe the username, they're reading into a buffer of size 100, because who's going to have a username bigger than 100? And so what the person does is they will send megabytes and megabytes of data as the username. And so strcpy will very happily write into the first 100 bytes of the username, and then it keeps going, and now you're writing through RAM, and you keep going down through RAM, and you eventually hit the code segment of a person's code, and then it overwrites the code with whatever's there, and so the person fills in as their username a bunch of assembly code, and then now the server is running arbitrary code that is passed to it by randos on the internet, right? This is a garbage function. This is a really, really garbage function. And C people will defend it, saying, well, you just have to be careful. And my whole thing is like, no, like anything that has resulted in billions of dollars of losses over the years is not a well-written function. I'm sorry. So, okay. So yeah, I will rant about C-style strings. I do not like them. Sam, I am. All right. C++ strings are just a night and day difference in it. And in fact, a lot of the reason why people hated the C++ language back in the day was because we didn't have strings. The string class didn't come in until halfway through C++'s lifetime. You know, like when I was learning C++, we had to do everything using C-style strings because there was no C++ string class. That was added in 98, I believe. And so, let me look at that. C++ string class. Yeah, and so when we took it, we had to use C-style strings, and it was garbage, and it was horrible. And so most companies just made their own string class because it was such garbage. Yeah, since 98, yeah, okay. So, yeah. All right, so the good news is you don't have to worry about any... The worst part of C-style strings is like when the strings expand or shrink, or you have to worry about the size of things. For your assignment, you don't have to. All you have to do is convert this function here into assembly. Okay. So okay. So how do you convert this into assembly? Right. So first, if the pointer passed in is null, just return. Okay. So if you pass in a null string here, then bail out, just return. Okay. Easy. Got a for loop, and this is a weird looking for loop, right? This is how for loops look like when you work with C-style strings, because you don't know how big the string is. Normally, if you were doing this in C++, it would be like for int I equals 0, I is less than str.size I++, right? You don't know how big the string is. So you go until there's a 0 byte. Okay? You just keep on going, keep on trucking. Maybe you're running through somebody else's RAM. Maybe you're segfaulting. I don't know. There's no way of telling. It's a C-style string. So, so basically what you're going to do is say, starting at the beginning, going to, I don't know where the end is. We're just going to keep going until there's a null byte. Okay? And so we're going to grab the ith byte out of the string. And I'll show you how to do that in assembly in just 1 second. If that character is an alpha, then randomly flip a coin using the rand function. You can call the rand function. You don't have to write it yourself. Modulus it by 2. So, Dolio, do you know how to modulus something by 2 in assembly? There is no modulus function. Can we do this assignment with what we know now? No. No, you can't. I'm going to teach you a new assembly today. Bit shift left. How do you modulus by 2 in assembly? All right. So if you have a bit pattern of this, if you modulus it by 2, you get 1, right? Because when you modulus by 2, it just returns the last bit. And if you have 101010 modulus by 2, you get 0 because that's the last bit there. Okay. So when you modulus by 2, it is doing a basically an AND of all zeros and a 1, right? Did I type the right number? Yeah, okay. So you're ANDing it with 1. If you AND it with 1, you get modulus 2. Okay. You guys understand? So ANDing something with 1, ANDing something with 1 is mod 2. Okay. That's it. You know, so easy. And that's why I told you guys before, hash tables. Some people do hash tables not with prime sizes. Prime sizes are very useful when you are doing double hashing and things like that. But with powers of 2 sizes, because the most expensive thing in hashing a lot of times is the modulus, right? Modulus is not necessarily very cheap, and in fact, it's rarely cheap. It's a division, right? And so on like ARM32, where you have no mod, that's like 80 cycles to do a mod, right? But if you do modulus by power of 2, then you just do an and that's it. You can do a modulus with 0 cycles, really, or 1 if you have to do it on its own line. But you can do an can you? Wait, maybe not. Maybe it's always 1 cycle. But either way, it's way cheaper than modulus, right? And you can only mod this way with powers of 2. That's correct, Muya. Yeah. And that's why some of the fastest hash tables out there have powers of 2 hash table sizes rather than prime sizes. And those are 2 different designs for hash tables. So if you're doing double hashing, it has to be a prime size. Basically, if you're doing this, then it has to be a power of 2 size. Hash tables are the best data structure out there. I'm a huge fan of hash tables. Maybe we'll do one in assembly. We'll see. Mod 8 would be the last 3 bits. Yeah, so if you wanted to mod 8, it would be 1 plus 2 plus 4 is 7. You do it like that. All right, you would AND it with 7. So it would be AND R0, 7 would do a modulus by 8. Yeah. Okay. That makes sense? So you guys know how to call rand. You know how to call C functions. That's fine. Do I include rand man 2 rand, or is it man 3 rand? 3 rand. C standard lib. Okay, then main.cc. I should include that. C standard lib. And redeploy. This is what I get for writing homework assignments while we have guest speakers in class. Then main.cc. Okay, so you guys are going to write this function here, asm SpongeBob, and it's just going to be a reimplementation of CPP SpongeBob. Okay. If you want to link together assembly and C++ code, you do it like this. You wrap it in extern C to do C-style bindings, and then you are going to make a file called asm SpongeBob, whatever, and fill it with code. I am not giving you any starter code on this one. You have to do it yourself. I'm not giving you a makefile. You have to do it yourself. Okay, it'll be a good experience for you. You can look at the past. You can look at ASMIF and basically use your programming skills, right? Your programming, like when you're a programmer, you should be able to look at an example and adapt it to your project, right? So I've given you guys, you guys have done functions like 2 or 3 assignments in a row now. You should be able to create your own .s file. You should be able to look at the old makefile and copy it over and adapt it to your needs, right? Okay, well, it's not going to be called asmif.f. I'll call it asm SpongeBob.f. And you just go through and change asmif to asm SpongeBob and look at the format of makefile and adapt it for it. I gave you a really simple makefile. It's nothing fancy. And so it'll be a good experience for you to make your own makefile and make your own .s file and get everything set up. It's like when you push the birds out of the nest and they have to learn to fly on the way down. That's your grade. Will there be an input tester? There will be. I literally made this while Zach and I had started a little bit before class, but there's no input tester yet. Okay. So yeah, the code is going to coin flip, and then if the coin flip is true, you uppercase it. If the coin flip is false, you lowercase it. I will tell you guys there is a faster way of uppercasing and lowercasing than calling a function. As a hint, if you look at the ASCII table, A is 65, lowercase a is 97. What is 97 what is 97 minus 65? 32. 32 is a power of 2. That's my hint. That's my hint for you guys. So there are clever ways of doing uppercase and lowercase using bit twiddling and things like that. Okay. So not going to say anymore. All right. Okay. Yeah. And so if it's an alpha, you uppercase or lowercase it randomly. If it's not an alpha, you just leave it alone. Move on to the next one. And then this you need to know. This you need to know. How to read and write to memory. Okay. So how do we read and write to memory? To the demos section. 16, 12, sure. Okay. So how do we read and write to memory? Well, this is for an integer. We're not doing integers, we're doing bytes. So let's see if there's do I have one for strings in here? I don't see one for strings in here. Well, the README does mention this. So if you want to read a byte or store a byte, it is STRB to read a byte and LDRB to load a byte. So this loads a byte and this stores a byte. Okay. And this command right here is the only command in assembly that is backwards. Okay, and so let me go through the format for load first. So this is how you read from a this is how you read from an array. Okay, so R1 is a pointer to an array, and R6 is how many in this case. You can use, again, you can use any registers you want. In C++, if you want to like let's say you've got char star str is equal to hello world, and so in assembly you would do this like this. You'd say load into register 1 the address of str. So you don't have to do this for this because it's being passed to you, right? But if you want to put your string in assembly, you do it like this. Don't worry about it for now. You don't need it for this assignment. So yeah, so you would either load it or it'd just be passed in as the R0 as the parameter. And so if you wanted to access, if you wanted to say str4 is equal to the letter A, then in assembly this would be, let's see, move into register 7. I believe that works. I think you can actually use ASCII codes in assembly like that. Don't quote me on it though. So, or you can just look up the ASCII code, which is 65, right? So you can do that as well if you want. And so yeah, and so there's 4 commands we're going to learn today. So the first is in the next 1 minute. So so if you want to write to a memory address, you can do it like this. So let's say R5 contains str, R6 contains 4. So you can store a byte containing R7 to R5 plus R6. That's how you do it. And so this is str 4 equals A. Okay. So str load and str load and store ints, 32 bits in other words, LDRB and STRB load and store chars. 8 bits. Okay. So if you want to read 8 bits at a time, or if you want to read 32 bits at a time, that's the difference between these bad boys here. Okay. It just stands for load and store, right? Load and store. So if you want to store 32 bits, you do that. If you want to load 32 bits, you do that. Okay. And the format with these square brackets is this. And so the first number is typically a pointer, and the second number is typically an offset. So the number of bytes to the right from the pointer. Technically, you can put those in either order because the assembler will just add them together, right? So when you do the load, it just adds those two numbers together, and it adds usually a pointer and a number of bytes, and that's the memory address that it loads to. That's the memory address it stores to, and so if you wanted to set square bracket 4 to be A, you put A into register 7, and then you store that into that memory address. And so what you're going to do is you're going to do a for loop that's going to be loading load byte, load byte, load byte over and over again, and then storing it back into the same memory address. Okay. Your class goes till 2, doesn't it? Oh, then that's right. This isn't CSI 41. Cool. Yeah, we got time then. All right. Yeah. So let's write a little bit of let's actually make a function maybe for you guys. Yeah. Let's do it. Okay. So I don't have to rush quite as much then. Still, it was nice having those guest speakers today. Okay. All right. So got a class here, and let's just make a new function called delete bees, and it's going to take in a char star. And remember, when you make a function prototype, you don't actually need a name for the parameter. You can put it in if you want, so you can let people know what you're expecting. Especially in this case where you don't know if it's a pointer to a char, if it's an owning pointer, if it's a non-owning pointer, things like that. But in this case, if you just see a char star, people are going to assume it's a non-owning string. That said, like, if you ever work with incurses, some incurses functions that you call will allocate memory, and some incurses functions you call will delete memory. And if you don't know which of them are taking ownership and which are not, then your code will be bad and you will feel bad. So the ownership question of pointers is do you guys understand what I mean by ownership? Like if you say like int star array equals new int 100, R is now the owner of 100 ints of memory, right? And so if you pass this to a function, like if you say foo R, did foo deallocate the memory or not? Who knows? Right? There's no mechanics in the language itself to indicate if ownership is being transferred to it or not. You just pass a pointer to it. You don't know if they deallocated it or not, or if they should deallocate it or not. Like if I don't use foo ever again, or if I don't use array ever again, then foo really should have deallocated that memory. But there's nothing in the language that indicates that. So that's why there are these things called smart pointers, and smart pointers handle ownership really nicely. There's unique pointer, and R equals make unique, right? So that whole thing, very useful. I would, if you're in the C++ world, I would use those rather than raw pointers to indicate ownership. Okay. Because if you have a unique pointer, nobody else can take ownership of that pointer. Right? You can't make a copy of it, right? It itself is the owner of that block of memory, and when the unique pointer goes out of scope, then it gets deallocated automatically. So if you pass a unique pointer to a function, you have to move it in, which transfers ownership from you into that function, and then it could possibly get moved back out, but if it doesn't, then it gets deallocated at that point. And so we really should have a whole lecture on smart pointers at some point, because I think I mentioned them in 41 for you guys, but they're really worth they're really worth about 15 minutes to learn because they're really nice. Okay, so anyway, that's not our topic for today. Our topic for today is this. Let's delete B's, or delete BS apparently. So Bob is that memory address here. Bob's name is that memory address here. Bob's initials. Bob's name is Bob Kearney. All right. And then let's delete B's from it. Delete B's Bob.name. And is that a string or is it a char star? Okay, it's a char star. Okay, so delete B's, and so link this with delete B's.s. Okay, so vim delete B's.s, global delete B's, delete B's. Okay. So, what do we start with? What do we start with? Do you need the space? No, you don't need the space. Spaces are more or less optional. Push LR. What are we going to be pushing? Are we going to need to save any other variables? All we're going to be doing is replacing capital B's with spaces, let's say. Should I? Push PC, push LR? How about we just start with pushing LR? Push link register. Maybe we don't even need that, but let's just start with that. It's a good starting place. And then we can pop it into the program counter later. Okay, so this is our sandwich. And if we are going to be using registers 4 through 11, then we can push those as well. But for now, let's see if we need them. Okay. So R0 is set to be the start of a memory block holding a string. Okay. So if we want to load from it, we can do it like this: load byte. That loads one char. Remember. Learning point for today. Learning point for today. LDR loads 32 bits from a memory address, and I think it has to be 32-bit aligned. 32-bit aligned means you can load from memory address 0, memory address 32, memory address 64, memory address 96, memory address 128. You guys understand? 120, 96, 128. Yeah. So it has to be divisible by 32. Okay. If I'm remembering the rules correctly, I don't believe you can misalign the LDR that way. Loads 8 bits from memory address. It can be any byte and. So ARM32 is byte addressable memory. So that means you load a byte at a time. You can't read a single bit from memory. You read a byte at a minimum, or you can load 32 bits. And there's other loads as well that we don't use very often. So you either load, your brain ran into a fatal error. Oh, yeah. Yeah, so you load either a byte at a time or you load 32 bits at a time. Those are the two most common things we do. And then on the other side, we have store, which stores 32 bits from a register to memory. It's also 32-bit aligned. And store byte stores 8 bits to a memory address. So these are the four new commands for you guys today. And again, you have your textbook that has plenty of examples. There's actually a lot of ways you can access memory other than the format I'm showing you guys right now with the square brackets. You can put something outside of the square brackets. You can put an exclamation mark on it, and there's variants on it. Like I said, whenever you do assembly, there's like the core language, and then there's like 9 million variants that are optimized for different patterns. For example, a common pattern that might help you on this assignment is when you read a byte from memory to also move the pointer one memory address ahead. And so you don't have to do a separate add operator to move the pointer. You can just actually read and increment the pointer at the same time. And you can see how to do that in the textbook. It's what I teach in my lectures is the core commands, right? Because it's very easy to become overwhelmed with like the 900,000 different commands there are in assembly. In reality, there's like 12. You know, like add, subtract, multiply, branch, compare, and now we're doing load and store, branch with link, push and pop. Yeah, that's about it. And then, the bitwise operations, maybe. Yeah, not a lot. There's not a lot of commands. Like you can do you can learn assembly very quickly. It's just if you want to make your code fast, then it's worth looking at all the different variants. Okay, I'm going to do read with post increment with write back, and things like that. But I don't usually lecture on those. How do you select which memory location to load from RAM? Great question. So the first thing we're going to do is we're going to load into a register and store violates the pattern of ARM32. The first parameter is the source, not the destination. Okay, so we'll leave that in a second. So load a byte. Okay, so we're going to load into register 1, and we are going to read from the pointer. So this function takes, in C++, it looks like this. It looks like delete void delete bs char star. Okay. So this is what the function looks like, right? And usually when you write assembly, I typically put what the C++ signature is, just because in assembly there's no way of indicating how many parameters you have, and so with this you can see like, okay, R0 is going to be str. It's a memory address, and so we just read from that memory address plus I don't know, 0, let's say. I don't know if that'll work actually. It might need to be a register. Let's see if that works. GCC-C delete bs.s, bad instruction pop PC. What did I do wrong here? Space. It does need a space. Yeah. All right. Okay. So yeah, this will compile. Okay. So you can put a constant there. Okay. So this will read the first byte from the string, and then we can do something like this. Compare. Let's see that. So that's going to be the first letter from the string. So compare R1 with the letter B. Let's see if I'm remembering that right. It does work. Okay. Yeah. So you could either do that, or you could use the ASCII code, which is 65, if you wanted, but the assembler does actually understand single quotes, and it will just put in 65 for you. So it makes your code a little more readable if you do it that way. So compare R1 with B, and if it is equal, let's say, move if equal, right? So we don't have to do a branch and then branch back. It's a one-line branch. I typically use a suffix. So move if equal into register 1. I'll put let's change it to a space, right? And then I am going to store byte R1, and And this is what I mean by it's backwards. I'm going to store from R1 into R0 hashtag 0. Okay. So read the first byte from the string. Is it a B? If it is, oh, my video went out. If it is, delete it. And let's see if it's still streaming. Good. Okay. If it is, delete it, and then write it back into RAM. And technically, I can make this conditional also, right? So it'll only bother writing back into RAM if it changed. But yeah, whatever. I'm just going to leave it like this so I don't confuse you guys. But in reality, I'd put the EQ there also, because there's no reason to do the write if it didn't change. So, yeah, okay. So let's compile G++, delete BS, and class.cc together. And I need, where's the other one? There's some other assembly file. Thanks for telling me past self. Compile with G++ class.cc. Yeah, class.cc. Delete bs.s and asm mess with s and grep asm mess with ssm. If you guys don't know the grep command, grep is amazing. When you have a large directory filled with code, you can hunt through it and find where this code is, and it is in 19class.s. Okay. Good. Okay. So if you're ever going to do anything like this, it's a good idea to just note which files you're using, because I've got this giant code directory. Right? So that will do that, and it compiles, and we run it, and uh-oh. Did we hang? What happened here? Let's make sure that I did this right. Seg fault. Actually, I might have actually done this one already. 19. Yeah, okay. Well, there we go. Yeah, so this should be load byte LDRB. Here, that's why it's wrong. Oh, no, this is a pointer. So name is a pointer, and then it's adding 1 to the pointer, and then storing it back. And so that's why it's going from Bob to Ob, because it moves the pointer 1 to the right. So why is our code segfaulting? Passing in a pointer here. Oh, because it's a... Oh, because yeah. Because this is actually a const, right? Okay. Yeah. So if you ever have a double quote like this in C++, that means it's actually constant string. You can't actually modify it like what we're doing here. So what do we want to do? We want to duplicate it. Really, is what we want to do. So let's do this. malloc Sterling +1 to hold the null byte. Remember how I said there's off by 1 errors left and right? There's off by 1 errors left and right. So this is going to allocate enough memory to hold Bob Kearney, and we're going to need the C string. Okay, we already got that. So this is going to allocate enough memory to hold Bob Kearney with the null byte. Don't forget it. And so we don't do this. It's bad anymore. Oh yeah, see, I did it right here actually. Properly. That's the proper way of doing it, right? So C style memory allocation, and then this is C++ style memory allocation, and I did a stir copy. Yeah, okay, look, check me out. Okay, well that's why it crashes if you don't, I think. All right, we'll find out. All right, so Bob is allocated equal to memory, and then we're gonna string copy into bob.name from Bob Kearney, and Sterling Bob Kearney, and I probably should put Bob Kearney into its own variable, shouldn't I? Yeah, why not? Okay, const char star Bob is equal to Bob Kearney. Then I don't have to keep repeating myself. Okay. So this is going to, this will copy Bob Kearney into name. And then down here we should deallocate, right? So free bob.name. This is C style deallocation. So that's how you delete things in C. And who do we have here? Address is using new. So delete square bracket Bob. Malloc is memory allocation, yeah. Mm-hmm. And there's a few different versions of malloc. There's calloc and realloc, and yeah. So calloc then clears and allocates, right? So it allocates memory and zero fills it. Okay. And then reallocate will allow you to adjust the size of a array. Changes the size of the memory block pointed to, the contents will be unchanged. If the new size is larger, the added memory is not initialized. If null pointer is null, then it's the same thing as malloc. And so you can use that to do the vector growth and that kind of stuff. Okay. All right. So, what do you mean by new? Malloc is new. It's new for you guys, maybe. And it's the C version of new. And so malloc takes a number of bytes to allocate. And so if you wanted to allocate 100 ints, how would you guys do it? Oh, did I... Why is that indenting? It's because I don't have the close parentheses here. Okay. How do you allocate 100 ints using malloc? I'm asking you guys while I look at this. yeah, to allocate 100 ints, I wouldn't do it either the way you guys suggested, actually. I would say int pointer array equals int star. Malloc actually returns a void pointer, which is a untyped pointer. And C++ doesn't like void pointers very much at all. So you're supposed to cast them to a pointer. You should do that in C as well. Malloc, and we do it like this. Size of int times 100. You might be like, why not 400? Well, you don't actually know that ints are 4 bytes. On some systems, ints are 2 bytes. So if you want to allocate 400 bytes, you might end up with 100 ints. You might end up with 800 ints, right? So if you're trying to allocate 400 ints, you actually need to do this. And so this is how to allocate 100 ints the C style way. And I hope you guys are appreciating C++ a little bit more after this, right? Because in C++, it'd be how do you allocate 100 ints the C++ style way. And that would be int pointer array 2 equals new int 100, right? You don't have, it just says give me 100 ints, right? So int our square bracket 100 is a stack allocation of 100 ints. Yeah, so that goes on the stack, whereas these are heap allocated. Okay. So these are permanent allocations until you free them. Okay, so I don't need these right now, so let's just comment these guys out, and let's see if our code works now. Ooh, yikes. What do I do here? Just remembering me. Non-type. Does not like that. Oh, don't. Don't give it the same name. Okay. Stir, and let's make sure I don't use stir elsewhere. No. Okay, good. Yeah, that was a big oof on my part. Okay, there we go. And so we hit a key to continue, and you can see, sure enough, our assembly code has erased the B from it. Okay. And so our assembly code worked. All right. See you. So basically, I will push out the updated demos to you guys. As a result of this, and the delete B's is what you can look at. And so basically what you're going to need to do is put this into a loop, right? So you guys know how to do for loops. So rather than just reading from 0, you keep reading until the thing that you read is a null character, and then you terminate. And that's your homework assignment. Okay? So you're basically just going to be reading a byte at a time from a string, and if you ever get to a null byte, you return. Otherwise, you just call the random function, and then call to upper, call to a lower if you like, or you can do it yourself using the bit twiddling tricks. That's your homework. So you guys got a week to do it, and again, there's extra credit available if you are in the top 25% of all performance students. Then you will get 25% extra credit. So as always, in this class, I really focus on efficiency and speed, whereas in other classes, I focus on correctness. For this class, correctness also matters. You won't get points if you're not correct. But that's can you say compare R1 with star /0? You could, or you could just compare it with 0, right? Because you load a byte, and if it's 0, then it's the null byte. But if you really wanted to, you could do that if you wanted. Just compare with 0. Or you can do a if you want to really be fancy, load byte and set, right? That would probably work. And so if you load a 0, then you can load byte and set, branch if equal to 0, to done, like that. Jump to done if we loaded a 0. Easy. Easy peasy. Okay. Why did you do times 100 on the C-style allocation again? We're bad out of class, but down here. Because we wanted 100 ints, right? So if you want to have 100 ints, you take the size of an int and multiply it by 100, and that'll give you 100 ints. So with malloc, you pass it bytes. This is how many bytes I want, and it doesn't know anything about the types or any of that stuff. It will just give you 400 bytes. Okay. With ints, new int here with the C++ style way, it's actually typed. And so the C++ language itself knows how much memory to allocate. You don't have to calculate how many bytes you're going to allocate using the C++ style way. And free and delete basically work the same way. So you free and delete, they're basically identical. But malloc's a little different because you actually have to do the math yourself to figure out how many bytes you're gonna get. Because malloc just takes a number of bytes and it gives you a pointer and address. It doesn't know anything about typing at all. Okay. So that's it for today, guys. Thanks for coming out. Hope you guys enjoyed the guest speakers. We'll probably do it again in a while if you guys are interested in that kind of stuff. And it is now time for game development. So, see you guys.